Okay, chapter 6 is on radicals and exponents. So we already started doing some of the radicals. Radicals involve this root symbol, the one over here. We only do square root, so I can say square root, or I can call it a radical. When you get to algebra 2, we'll do different kinds of roots besides square roots. But anything with that symbol we call a radical. Now for vocabulary, okay, this symbol is the radical, and I will call, when I say radical, I'm just referring to the symbol. The number inside the symbol, the radical, is called the radicand. So if I say the radicand, I'm talking about the number inside the radical symbol. Okay, now example 0 is because we already kind of learned these. These are all rational answers. They're all perfect squares, so they have a nice answer. There's no work to show. You guys are very good at these, actually. So for example, for 0a, the square root of 25 is just 5, because 5 squared is 25. No work to show. For B, the square root of 121 is 11, because 11 squared is 121. Okay, for C, it's a fraction, but remember, with a fraction, we just have to do the numerator and denominator individually. So the square root of 9 is 3, and the square root of 49 is 7, and because everything comes out to be perfect squares, this is a rational number. Okay, for D, we haven't done something exactly like this, but we could do it. Okay, so it's really saying this is 5 times the square root of 36. So 5 times, now what's the square root of 36? Square root of 36 is 6, so it's really saying 5 times 6, which is just 30, and I can multiply them because they're both rational. Okay, let's see, for the next one, I'm going to bring down the 7. Now the square root of 100 is 10, because 10 squared is 100, so 7 times 10 is 70. Okay, for F, again, I'll evaluate each radical separately. So the square root of 25 is 5. The square root of 9 is 3, so 5 times 3 is 15. The square root of 49 is 7. The square root of 16 is 4, so 7 times 4 gives me 28. And these were all rational answers because they came out to have whole number solutions. They're perfect squares. Okay, what we're going to add today is what we do when you have an irrational radical, meaning it doesn't have a perfect square, so I can't evaluate it in my head. So for example, the square root of 45, if I do 6 times 6, that's 36. That doesn't work. If I do 7 times 7, that's 49. That's too high. Okay, so if I want to simplify an irrational radical, I simplify by factoring out any perfect squares from the radicand, so I can make the radicand smaller. Okay, before we started, I'm going to list some of the perfect squares. Let's see. Now, the square root of 1 is 1, but that's not that helpful to me. Okay, now I know the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. What else? The square root of 25 is 5. Okay, what else comes up? I'm going to skip to the square root of 100 because that's the one that comes up below. Okay, we know these pretty easily in our heads. So I'm going to keep these in mind when I'm trying to figure out how to simplify these. Okay, so the first thing I'm going to do is I'm going to look at the radicand here. The radicand is 45. Okay, I don't know the square root of 45, so I'm trying to think of two things I multiply to get 45. And I want one of them to be a perfect square. So for example, 45 could be 3 times 15. Okay, do I know the square root of 3? No. Do I know the square root of 15? No, neither are perfect squares. So let me think of something else. What else can I multiply to get 45? I could do 9 times 5. Now, do I know the square root of 9? Yes, the square root of 9 is 3. Do I know the square root of 5? No. Okay, so how I simplify this is the square root of 45 is the same as the square root of 9 times the square root of 5. Because 9 times 5 is 45. Now, the square root of 9, I know the square root of 9 is 3. The square root of 5, I do not know. It's irrational, so I leave it square root 5. Okay, so this is my simplified answer. It's 3 square root 5. This is a better answer than the original answer because the radicand used to be 45 and now it went down to 5. We're going to try some more until we get used to them. Okay, before I start it, the first thing I look at is, do I know the square root of 12? I do not know the square root of 12. It's not rational. Since I don't know the square root of 12, I have to think of two things I multiply to get 12 so that one of them is a perfect square. Okay, so what are we thinking? We're thinking it might be 6 times 2. Do we know the square root of 6 or 2? No. What about 4 times 3? Do I know the square root of 4? Yes, I do. I could also check this list here and try to use these numbers to make 12. If I do want to get 12, I could do 4 times 3, and that would work. So I'll probably switch back and forth between the two methods. So 12 is 4 times 3, so the square root of 12 is the square root of 4 times the square root of 3. Now the square root of 4 is 2. The square root of 3 is irrational, so I leave it as square root 3. Okay, so 2 square root 3 is my final answer. And I always put the rational part first, even if it doesn't come in that order. So I might switch it up for the next one. Okay, now I'm going to look at the C as square root of 18. Again, it's irrational. I do not know the square root of 18. It doesn't come out to be a whole number. Okay, so I need to think of two things I multiply to get 18, so that one of them is a perfect square. Now in your head, you can be thinking of factors that equal 18, or I could go down this list and see if I can use any of these numbers to make 18. Is there 4 times something to give me 18? No. Is there 9 times something to give me 18? Yeah, I could do 9 times 2, right? Okay, I'm going to write it backwards. I'm going to say 2 times 9. And because I want you to see when it's written backwards how you do it. Okay, square root of 18 is the square root of 2 times the square root of 9. Okay, now which one do I know the answer to? I know the square root of 9. That's the one that's a perfect square. Okay, now the square root of 9 is 3. I put the 3 in the front, even though the 9 came second, because whatever the rational factor is, that's the one that goes first. The square root of 2, I did not know, so I keep that in the radical. Okay, so my answer is 3 square root 2. And remember, I had to put the 3 in front because that is the rational part. If I always put the perfect square first, then I don't have to really rearrange it. If I had done 9 times 2, it might have been easier to do in my head, but it actually doesn't make a difference. Okay, I'm going to go to square root of 24, and if you get it, you can work ahead of me. Okay, the square root of 24, I do not know. If it were 25, I could figure it out, but 24, I don't know. Okay, you can either think of factors in your head of 24, or I can reference this list and see if I can use any of these numbers to multiply to get 24. Okay, let's see. 16 times something to get 24? No. 9 times something to get 24? No. 4 times something to get 24? 4 times 6. Let's do 4 times 6. Okay, and I like to put the perfect square first, but you don't have to. You just have to make sure you put the rational answer first. Okay, the square root of 4 is 2. The square root of 6 is irrational, so I leave it in the radical. Okay, that's my final answer. That's a good answer. Okay, and you're always going to show me that first step so I can see how you got it. Let's keep going. Square root of 40. Square root of 40 is not a perfect square, so I don't know the exact answer to it. So I'm going to think of two numbers I multiply to get 40. In my head, I can be thinking of factors like we listed up here, or I can be checking this list, because if I use the list, I can normally find it. Okay, to get 40, can I do 4 times something? Oh, I can do 4 times 10. So the square root of 40 is the square root of 4 times the square root of 10. The square root of 4 is 2. That's why I picked it. The square root of 10, I do not know. It's irrational, so I leave it in the radical. Okay, I'm going to keep going. Okay, now this is the square root of 75. Again, I don't know what the square root of 75 is. So I'm going to think of two things I multiply to get 75. Now the thing about 75, I can absolutely check this list and look for stuff, but when I see 75, I think of money. I think of quarters. Why do I care about quarters? Because quarters are perfect squares. Quarters are 25. So to get 75 cents, I need 3 quarters, or I need 25 times 3. But it's easier in my head if I think, okay, that's made out of quarters. 3 quarters, 3 times 25. Okay, the square root of 25 is 5. The square root of 3 is irrational. Okay, I'm going to keep going now. 125. I don't know the square root of 125. It's irrational. Okay, I want to think of things I multiply to get 125. Now, when I look at 125, I still think of quarters. I know some of you guys just have bills and stuff, but okay, I'm thinking of quarters. Now, how many quarters does it take to make 125? Okay, 4 for $1, 5 for 125. Okay, the square root of 25 is 5. The square root of 5 is irrational, so I'll leave it alone. Okay, H, root 300, don't know the answer. Okay, no, I could use quarters on this, but when I see hundreds, I know the square root of 100. So anything hundreds, 1100, 500, 700, 300, I'm going to use 100. Okay, 100 times 3 gives me 300. The reason I use 100 is because the square root of 100 is 10. The square root of 3 is irrational, so I leave it like that. Okay, now let's see. Now the square root of 36, I do know the square root of 36. What is the square root of 36? The square root of 36 is just 6. So there's no work to do. If I wanted to do it a complicated way, I could. But always check first and see, is it a rational answer? If it's rational, I can just write the answer. I don't have to do all these extra steps. Okay, last ones. We're throwing an extra number in the front. Okay, so it's 7 times the square root of 20. Let me bring down the 7. Now, do I know the square root of 20? I do not. It's not rational. Okay, so I want to think of 2 things I multiply to get 20. Let me check my list of perfect squares. Can I do 4 times something to get 20? 4 times 5 is 20. And if you need to bring your times table out, bring your times table out. No shame in a times table. Okay, so 4 times 5, but it was square root 20, so it had to be square root 4 and square root 5. Okay, let me bring down the 7. It's just hanging out there. Now, what is the square root of 4? The square root of 4 is 2. Okay, I don't want to just write 7, 2 because it looks like 72. So you can put a dot or you can put parentheses. The square root of 5, I have no idea. Okay, I'm going to do one last step because I have the 7 in the parentheses 2. That's really saying 7 times 2. So 7 times 2 is 14. Then the radical stays square root of 5. Okay, that's my final answer. And these are pretty much the hardest we're going to get on these. Okay, so for K, let me bring down the 5 first. Now the square root of 99. Do I know the square root of 99? I do not. Okay, so let me think of 2 things I multiply to get 99. And if off the top of your head you already know, just fill in the blanks. If you have trouble thinking of them, just check the list. Can I do 4 times something to get 99? No. Can I do 9 times something to get 99? Yeah, that seems right because it has so many 9s. So 9 times 11. Okay, let me see. The square root of 9 is 3. And again, I'm going to put it in parentheses. I'm going to put a little dot so it doesn't look like 53. Okay, then the last step is just multiplying the coefficients. So 5 times 3 is 15. Square root 11. Okay, last one. It says 11 square root 50. Let me just bring down the 11 first. Do I know the square root of 50? I do not. If it was 49, I would know it, but 50, I don't know. Okay, now 50 looks like 50 cents to me, which means I'm going to think quarters. How many quarters make 50? 2 quarters. And since it was a radical, I'm going to keep the radical. Okay, let me bring down the 11. The square root of 25 is 5, and I'll put parentheses so it doesn't look like 115. 11 times 5 is 55, square root 2. Okay, and that's the best I can do.